Hello class, today we're going to learn about the counting principle. So if you could turn your note packets to the page that says Counting Methods and Sample Spaces, this is where we will begin. Example 1. Miss Bailey wishes to order a pizza. She must choose one meat and one veggie topping. She wants to know how many different pizzas she could make based on her favorite toppings. So as you see from the box below, I've listed my favorite meat toppings, which are pepperoni, sausage, and ham, and my favorite veggie toppings, which are green peppers, onions, and mushrooms. We are going to, in option number 1, make a list of ordered pairs, which means we're going to be listing out all the different pizzas we can make with my favorite toppings. Remember, we can only choose one from the meat section and one from the veggie section. So remember, an ordered pair is in parentheses. So if I start out with my meat being pepperoni, one pizza could be pepperoni and green peppers. Another pizza could be pepperoni with onions. And a third pizza could be pepperoni with mushrooms. Maybe I'd like sausage as my meat. So I could have sausage and green peppers, sausage with onions, or sausage with mushrooms. So right now I have 6 total different pizzas I could make, but I'm not done because I could also have ham and green peppers, ham and onions, or ham and mushrooms. So as you see, if I used one meat and one veggie, I can make a total of 9 different pizzas, one meat and one veggie option. Now, instead of always having to list out the different options, we could draw a tree diagram to see all 9 of our options. And this is what I was showing you on Friday. So here's how the tree diagram would look. The first thing you're going to do is you're going to choose your meat. So we have pepperoni, sausage, and ham to choose from. Once you decide on your meat, you then have a veggie option. So if you chose pepperoni, we have 3 different options. We can now have green peppers on that, onions, or mushrooms. So there's 3 pizzas. Maybe you chose sausage. If you chose sausage, you still have 3 different veggie options. You could have green peppers, onions, or mushrooms on that. If you chose ham, you also have 3 different options: green peppers, onions, and mushrooms. So as you can clearly see, you can now have 9 different pizzas made, and you can see them all on your tree diagram. As I said, you don't always want to list out all of your options. So the counting principle allows you not to have to make any lists. The counting principle says, when one item is selected from each of 2 or more lists, the total number of possible combinations is the product of the number of items in each list. So because we selected one meat and one veggie, we can use the counting principle to find our total possible pizzas we can make. So we had a meat option and we had a veggie option. There were 3 different meat options we had. We had pepperoni, sausage, and ham. We also had 3 different veggie toppings. We had green peppers, onions, and mushrooms. So if we take the product of those 2 numbers, we're going to get that 9 total possible outcomes for our pizza options. Now let's keep working with the counting principle. So let's look at example number 2 on the next page. A store offers 5 flavors of ice cream: vanilla, chocolate, strawberry, peach, and raspberry. A sundae can be made with either hot fudge topping or marshmallow topping. If a sundae consists of 1 flavor of ice cream and 1 topping, how many different sundaes can we make? So A asks us to actually list out our ordered pairs. So again, remember, we're choosing 1 ice cream flavor and 1 topping flavor. So we could have vanilla with hot fudge or vanilla with marshmallow. Chocolate and hot fudge, chocolate and marshmallow. Strawberry and hot fudge, or strawberry and marshmallow. We could have peach and hot fudge, or peach and marshmallow. And last but not least, raspberry and hot fudge, or raspberry and marshmallow. So as you see, if we were to count up how many total different options we have, there are 10 sundaes total that we can make choosing one ice cream flavor and one topping flavor. Now let's look to see how this would be in a tree diagram. So the first thing you're going to choose is your ice cream flavor. And we had 5 different ice cream flavors to choose from. There were vanilla, chocolate, strawberry, peach, and raspberry. And from each of those ice cream flavors, you had 2 toppings, hot fudge and marshmallow. So you have to go branch off of each ice cream flavor with your toppings. And now from your tree, you can see all 10 different ways to make a sundae. C asks us to verify our answer above by using the counting principle. Again, because we're choosing one ice cream flavor and one topping, we can use the counting principle. So we have our ice cream flavor and we have our topping. There were 5 ice cream flavors. There were 2 topping flavors. So when you multiply those numbers together, you get 10 total sundaes that you can make. Now, why is it so important to know the total? In probability, remember, probability, the answer is always going to be a fraction, and the denominator of that fraction is always your total. Now, you are not going to always want to list out your different options to find that total number, so sometimes using the counting principle will help us find that total. So let's look at some examples on the next page where we're not going to list out each option. Question number 3 says, Yang has 4 suits, 10 ties, and 8 dress shirts. How many different outfits can be chosen? So I'm not going to go through and say what color shirts he has and ties that he has. I'm going to just use the counting principle to find the total number of outfits he can choose. So my options are suits, he'll have to have a tie, and he'll need a dress shirt. There are 4 suits, 10 ties, 8 dress shirts. When you multiply those numbers together, that gives you your total. 320 outfits total. Question 2. Donna's Deli offers 18 kinds of sandwich fillings and 6 kinds of bread. In how many ways can a sandwich be ordered at the deli? So we have sandwich fillings and we have our bread options. There's 18 sandwich fillings. There are 6 different bread options. When I multiply those numbers together, I get a grand total of 108 different sandwiches that can be ordered. Question number 5. How many outcomes are possible if you roll a die 3 times? So I have my first roll, I have my second roll, and I have my third roll. A standard die, there's 6 numbers on a standard die. So for the first roll, there's 6 different numbers I could get. The second roll, there's still those same 6 numbers I can get. And the third roll, there's still 6 numbers I can get. When I multiply those numbers together, I get a grand total of 216 different outcomes I can get by rolling a die 3 times. Question number 6. In how many ways can a 4-question true-false quiz be answered if each question must be answered? So you're not allowed to leave any blank. So again, we have 4 questions. So I'm going to put 4 blanks for question number 1, question 2, question 3, and question 4. Now, because this is a true-false quiz, your options are either it's true or it's false. So you have 2 options for each question. So 2 for question 1. There's 2 options for question 2. There's 2 options for question 3. and 2 options for question 4. When I multiply those numbers together, I get a grand total of 16 different ways that this quiz can be answered. Question 7. Virginia tosses a coin 6 times. So now we're going to have 6 blanks. For toss 1, toss 2, toss 3, toss 4, toss 5, and toss 6. When you toss a coin, your options are heads or tails. So that's 2 options for each toss. When I multiply those numbers together, there are 64 possible outcomes you could get when you toss a coin 6 times. Question number 8. There are 6 roads from Pittsford to Syracuse and 3 roads from Syracuse to Albany. How many different routes are there from Pittsford to Albany? So the first route we need to take is from Pittsford to Syracuse. Then we're going to go from Syracuse to Albany. So if we want to get from Pittsford to Albany, we're going to have to stop in Syracuse, it looks like. We have 6 roads we can get from Pittsford to Syracuse, and 3 roads are going to take us from that Syracuse to Albany. So that's 18 different routes from Pittsford to Albany. That's all the questions we're going to practice for today. Your homework tonight is going to come from your homework packet. It's going to be called the Counting Principle. So you'll notice the page says Counting Principle at the top. And you'll need to do both the front and the back of this page. And don't forget, you have another weekly review that's coming this week. Weekly review number 27. Oh, actually, I think it's weekly review number 26 this week. So weekly review number 26 is due on Friday, so be sure you're working on that as well. I'll see you all tomorrow.